Today we're going to be solving HTTP Server 1 for this particular challenge. We're going to read through each one of these releases. We're going to try to understand as much as we can, and then we're just going to code it all out. Over the next few days, we're going to be using HTTP Server 1 to build onto HTTP Server 2 and then HTTP Server number 3. Today, we just want to know a little bit about what's coming in and what's going out. So we want to build a server that can listen for requests and then respond appropriately. So if we're just starting right over here, we're just trying to build an HTTP server using Python. And we're not trying to become experts at building servers. There's many other tools that do what we want to do already. So we're talking about Django and React and Rails, and every single modern framework already has an HTTP server built in. We want to learn mostly about, just a little bit about how HTTP works, but in a larger context, how do we use object-oriented programming and those principles and separation concerns, single responsibility? We want to do all of that with this particular challenge here. So, release 0, we just want to say hello world out to the user. So HTTP servers use TCP/IP, which is brought to us through the socket library that's built into Python. We don't have to learn anything from scratch, it's already there for us. All of this code is already in server.py. And if we're just going line by line, line number 1, we are importing the socket library. Again, it's actually just built into Python. So we get to just import it, and then we have access to it. This socket, this server, is a local variable to the server.py. And what we're doing here is we've got the socket, and inside there's a method called socket that's going to take in 2 arguments, the AF INET and the sock stream. You don't really need to know all about this, but if you want to know what they are, AFNet is to define the address family that we're using, and sock stream is the type of socket that we're going to be using. You don't need to know this. This is just built in for us. This next line is pretty important. We're saying that we want to bind the server to localhost, which is the host, and 9292, which is the port. Now, localhost just means literally your machine, the local host. Like, your particular machine is localhost. So my machine, I'm localhost, and I'd just be connecting to my machine. You can have a localhost 9292 on everyone's computer. It's just your particular computer. If you want it to connect to somebody else's computer, you just exchange this with a public IP address and some port number, and you'll be able to connect to them as long as you're on the same Wi-Fi. If you want to connect to an actual website that's being hosted by a real server, then you just have to put that there as well. So I've created a server. I'm going to bind it to this particular port, and I'm going to just print out waiting for connection and listen. I'm just listening for whatever comes in. The moment something comes in, we're going to save it under client connection. And then we print new connection received and close it out. We get 2 things for free. One of them is client connection, and the other one is client address. Since we're not using client address, I'm just going to put an underscore in the front, like you see right over here, and just ignore it. This underscore in the front just tells other developers, hey, you have access to client address, but we're not using it anywhere right now. If you want to use it, feel free to grab it, but you just take the underscore in the front and rename it as client address. So let's try it out. So I've cloned this down already from the internet. So let's just make sure that I'm pointing to the right place. So I've got India Platoon right over here, and I've checked out to a branch called My Solution in India. So I'm going to run Python server.py, and there it goes, waiting for connection. That's line 5 right over here. It's now listening and just kind of pausing on line 6 until we're able to hit it on line 8. Now, if we jump back into the README right over here, it's just waiting, just like you see over here. So we can make a request to it using 3 different things. We can use Google Chrome, we can use Postman, or we can use curl. Postman is a little buggy right now, so I have to figure out what's going on there. So let's try using curl. So curl, if you want to read a lot about the documentation, it's all right over here. But essentially, it's a library that's built into your command line to make requests on your behalf. So whenever you go into anything like Google Chrome right over here, and you type in something on the URL, Google Chrome is the one that's making a request. When I want to make a request with curl, it's curl making the request. So all I've got to do is copy this, and then it will make a GET request to localhost 9292. So I'm curling localhost 9292. So this is running, this current one right over here. I'm going to hit the plus sign and have two windows open. One of them, number one, is the Python server, and number two is just another terminal. If I hit curl 1992, I get this weird error message. That's okay for right now, but let's go back to number one. It says waiting for connection, and you saw that it was waiting just before, and then it hit new connection received, and that's what's going on right over here. So we know that we successfully heard a connection going on, and then we hit new connection received. I think that's all we want for this first portion. So we successfully completed our first request. Actually, no, I completely skipped this one. So let's respond to every single request with hello world. Let's see if we can do that. So I'm going to, I have my client connection here on line 8. Right now I'm just printing out new connection received, but I want to respond to the client who spoke to me. I want to say, hello, I acknowledge that you made a request to me. So client connection is a socket object, and we want to find a method that can send the data over there. So we're going to click on this right over here. And we're going to look for some sort of method on this page. Now I'm just kind of looking through something with, it says, is a socket object, and we're looking for a method that can send data. So I'm guessing there's going to be a socket dot, which there are 212 other ones. Is there something like a send method? Oh, it's right over there. And when I look at this right over here, there's a couple things. One is there's a socket.send, and there's also a socket.receive. I have no idea how to use this, so I'm just going to copy this, put it up top here, and then Python example. Looks like other people have asked for it. And when I take a look over here, there is a tutorial from realpython.com, which is very nice. So let's just look up socket.send, and there's 8 of them. So I'm just going to take a look at the second one, third one, fourth one. Is there an example of this anywhere? How about just looking at .send? Ah, okay. So it looks a little bit strange. I'm sending, oh, that's send all. It looks like I am going to send, I can just do socket.send some sort of data, which is pretty nice. All right, so now what I can do is I can just try this out. I can do client connection, .send, hello world. Now when I start the server up one more time, it says waiting for connection. And I've got line 9 right over here. If I make a request from this second terminal, nothing happens. It's not printing out the way I expect, but it did say, oh, it blew up. Waiting for a connection, and then it blows up here on line 9. Okay, so it worked before. We know that line 9 is broken because that is the only thing that we added. And I don't know what this means, so I'm just going to Google that, see what happens. It says a bytes-like object is required, not string. Looks like I'm sending back a string, so they want me to create a byte-like object. So I'm just going to Google that. I'm pretty sure someone has come up with that issue before. And there it is. It's that first one right there. Read through this question on your own. But it looks like, oh, this looks like a really easy one. If I just do hello world.encode, maybe that'll turn it into a byte-like object rather than a string. So dot encode. So I'm going to run my server again, still waiting for a connection. You see that right there. And I'm going to run Localhost 9292, and you can kind of see this tiny little thing over here that says hello world. Let's add a couple of lines in the front, a line in the back. Let's try this one more time. I'm going to restart the server, jump over here, run it again, and there's that hello world with the new line before and after. So I made a request to the server from my client. The server's here on tab number 1. It says it was waiting for a connection. I made the request. It fired back off hello world. And then on the server side, it says new connection received, and then it closed itself out. So we know that we need to encode all strings as bytes. Maybe this dot encode does that for us, which is really nice. So we've successfully completed our first request and response cycle, and that's really the entire internet. It's a little weird. Right now we're running the server on tab number 1, and we're running the client on tab number 2. But more abstractly, it's the same concept that allows like a California server to respond to a request made in a New York City browser. So let's keep our server running. Right now we are making one single request, and then everything stops. So let's just use a while loop. And we're going to modify server.py so that it just keeps running over and over and over again. So when I look at this right over here, I probably need to put it, let's see, I need to create my socket. I need to bind it to 9292. I'm printing waiting for connection. That's fine. That's okay. Maybe I'll put this right before. So I'll do while true, which will always evaluate to true. And I'm going to move all of this down over here. So basically what's going to happen is while true is going to execute over and over again. Line 6 it says waiting for a connection. It's going to listen for something. It's going to go through all of this and then close. But while true, since I reached the very bottom here, while true is just going to loop over one more time. So once I finish 13, I come back up to 6, and it goes over and over until I shut it off. Hopefully this will work. Waiting for connection, like we saw. I'm going to let me just clear the screen here. Curl 9292, and you can see that this is still running. Waiting for connection, new connection received. Waiting for connection. Let's make one more. Hello world, that's the response I get. Going back to the number 1, and there's that new connection received, and again, it's waiting for a connection. So we have this while loop that basically keeps the server running at all times. All right, when we jump over, we're going to go to this HTTP protocol right over here. We know that the HTTP protocol has requests and it has responses. We need to reformat our responses so that they look correct and that you can actually get something in return. So if you want, we've been doing stuff inside of curl because we just get some sort of text-based thing that comes back. If we want HTML to show up in Chrome, we have to have at least these following things inside of our return string. Right now, all we're saying is hello world. But if we want to send them back to some HTML, it has to be formatted in a very specific way. Specifically, it has to have protocol, the content type, the content length, a blank new line, and then the body of the response, which is the HTML itself. So these are the headers, and then this is the body of the response that's coming back. Between everything, we need a carriage return. Okay, that makes sense. So HTTP protocol, carriage return. Content type, carriage return. Content length, carriage return, so on and so forth. So instead of responding with hello world, we want some basic HTML. Let's see if we can get this to show up there. We want to modify the server.py and make another request with curl. Curl doesn't parse HTML, so we should just get the string back. Once the curl output looks correct, we're going to try it with the browser. I don't know, let's give it a shot. So we've got all of our code here right now, and I want to create some HTML that goes inside of here. It's probably going to get really messy if I try to create it all on the fly, so let's create a new function. I put it right at the top called def create HTML response. All right, I know I'm going to need this at some point, so I'll just call this HTML equals a string of that. Now, I'm going to copy and paste this. It looks like we need a whole bunch of stuff, so I might as well bring it in here. I'm going to comment this out. I know I'm going to need to return a formatted string. So I'm going to do, it looks like HTTP protocol, okay. So status code, reason phrase. Okay, so I know I'm going to need to pass over 1.1, probably a 200 status code, and okay. Followed by a carriage return. Content type is equal to, I think, text HTML is what we're looking for. \r, \n. Content length is actually going to be the len of HTML. Those parentheses, \r, \n, \r, \n again, because I have the blank new line and then another blank new line, and then finally we have the body, which is just going to be HTML. believe we've covered everything. So we've got HTTP protocol, content type, content length, new line again, and then the body itself. And my guess is, can I make this correct? So what we're going to do is we are going to do create HTML response, call it, and then encode it. So I'm going to kill the server, run it again, it's waiting for a connection, and hopefully all of this goes well. I'm going to jump over here, make the curl request, and there you go. I got my HTML body right over there. Now it's still running, so I can actually go back, go to localhost 9292, and notice that hello world. It's currently in a paragraph tag. Just to make sure that we're looking at the right thing, let's kill this and make it an H1 so we make it really, really big. Running the server again, refresh, hello world, we know that we're dealing with the right thing. Now, I'm going to prematurely optimize here. Not that I recommend this in general, but why would I encode the output of a method that I create? Why can't I just do .encode right there? I should be able to do this and remove the .encode from this method here. Let's see if that works. All right, it looks like that still works. The idea here is I don't want to have a bunch of method chaining off of responses when all the work should be done inside of the HTML response. The HTML response, you know that you're going to need to create an encoded formatted string. So just have it right over there. Let's take a look at our next requirement. Okay, we did this one, and let's jump back over to release number 2. So far we're completely ignoring the request. Makes sense, we're focusing on the server right now. We want our server to be able to respond in different ways depending on what kind of request the client sends. So I guess if somebody wants to send over a GET request or post to a certain URL, we want to keep track of that as well. We're going to have to decode it. Okay, so we encode on the way out, and we need to decode on the way in. So once we figure out how to receive data, we need to print it to the terminal. You should have something like this. Okay, all of this stuff. Interesting. All right, based off the URI, we want to be able to route the page to the user to different pages. The job is to parse the request, get the URI. If it's a slash, respond with hello world, just like we have. If it's slash time, respond with the current time is sometime over here. All right, so I need to be able to, I've been able to send data using the .send method, but if I wanted to receive data, let's take a look at the docs and see if there's something. I know that there's I believe it was REC, looks like receive message, RECB. Is there something that just RECB? Let's go back up to the first occurrence of this. Looks like I can receive some stuff. So let's take a look at this. Again, I don't know how to use this whatsoever. It's probably going to take me over here. Let's take a look at .recb. The way that I know that is if I Google this and I take a look at Python example, I know because I've already done it that it's going to be actually in this tutorial. So it looks like I need to receive 1024. On earth is 1024. Let's go back up to the first occurrence of here. Okay. Data equals connection.receive 1024. What does 1024? It says don't worry about it. Let's see if we can find a little bit more. The buff size argument of 1024 is the maximum amount of data to be received at once. It doesn't mean that it will receive. So if you send something that's over 1024 bytes, it's going to be angry. But it will, the maximum amount of bytes that it'll take is 1024. Interesting. All right, so we know that we need to grab the connection and basically receive some stuff. So let's do this. Let's get rid of new connection received. We don't need that. But right after, we'll do client connection that receive, oh my gosh, 1024. And we'll save that to request data, because the client is making a request with some sort of data, and we're just going to get that and embed at this point, because I want to play around with this a little bit. So what I'm going to do is I'm going to import embed from the top. So from IPython import embed. When I do it now, and I run the server, and I make a request, it's just gonna, oh, that's not what I wanted. Oh, that's because I am stupid and did not type it all the way through. So let's go back here and Python server.py, come over here, make the request. It's gonna hang out for a little bit because I'm stuck inside this embed. Now, if I take a look at request data, you can kind of see I get this weird B, but I have all of this information over here. And I'm specifically looking for this slash. So I'm making a get request to this slash right here. What is this type of underscore? Underscore is shorthand for the thing that was just returned. It looks like it's a byte. Well, I don't really know how to deal with bytes. Oh, this is where that decoding comes from. So it looks like I need to sockets in Python receive data as bytes. I need to decode it. So grab this. Maybe I will do request data dot decode. I have two dots there. Oops. Only one dot. Dot decode UTF-8. All right, this looks a little bit more promising. There's no B in the front. So if I do type of underscore again, looks like I've got a string. Now for me, all I want to do is get this right over here. I just want that. So the shortest way for me to get it, if I just go A equals this whole thing, and I just want to get the second, it looks like it's some word, some HTTP verb space, the URI. I just want to get the URI, so I'm going to split on spaces. So now I've got a bunch of arguments, but I know the second one is always going to be the that slash, because the way that the client sends stuff over using curl is always going to be the same. So I can safely say that split of 1 is going to give me the URI. So now I'm starting to get into this place where I am writing everything inside of here, and I don't want to do that. So I want to actually pass the entire connection wholesale over to the request. So I'm just going to say, maybe I'll just actually let's just write all the code out, and then we can figure out how we can change that up later. So the request data is equal to that. All right, and then I know I need to decode this, so I think it's decode UTF-8. Decode UTF-8. So now I've got the request string. So this is just A at this point. Okay. And let's just say the URI requested. Okay, let's just say requested URI is equal to request data at 1. Oops, nope, that's split on the spaces at 1. All right, and now we can do two things. If requested URI is equal to slash, do one thing. Else if requested URI is equal to slash time, do something else. We already know what we're going to do with create HTML response. So I'm just going to move this up here, and that should be good. Next, we've got this one over here, and I'm going to do the same thing with a separate method called create HTML time response. Now this doesn't exist yet, because I'm going to come up here and basically copy the whole thing. Copy this down, pass this in, HTML time response. And I'm going to say the current time is, and I'm just going to do current time is equal to datetime, now, stringify time. It looks like I need to bring in the datetime library. And I don't know how to stringify this, because if I go import datetime down, import datetime down over here, and I do datetime now, I get this weird datetime object, and I don't want it to look like that. What I want to do is I want to take this from here, and I want to stringify it so that I get the current time is 15:24, 3:24 p.m. So how do I stringify the Python datetime? All right, let's take a look at this. Oh, it looks like there's stringify time with some, okay, hour and minute and second. Let's just do hour and minute. So I'm just going to grab this whole thing. See if this works. If I just tack that onto the end, can I do this? Let's find out. 15:25. Yeah, that one works for me. So the current time is, so it's going to be this whole thing copied and pasted here. The current time is current time. 4-minute string. The current time is blah, and I think this should work. Let's find out if it does or it does not. I'm going to kill the server. I'm going to get rid of my embed, which is already gone, which is nice. And I'm going to load this server up. The address is already in use. I'm just going to change the port because my computer hasn't refreshed yet. I've changed it to 9291. It's waiting for a connection. I'm going to make a curl request. I'm going to clear the screen. 9291 without anything at the end, so just slash. It should say hello world. Fantastic. What about 9291 slash time? What will it say? The current time is 15:26. You can take a look right at the top right. We got 15:26 once more. Let's try it using HTML. I mean, not HTML. Let's try hitting this from here. 9291. It says hello world. That's what I expect. If I go slash time, the current time is 15:26. So it did exactly what we wanted it to do. So we just did release number 2. Let's take a look at release number 3. Okay, so follow the single responsibility principle. So we're not doing a great job of separating concerns. Everything is in one giant file. There's a lot of kind of repeated code, so it's not doing terribly well. So our job at this point is to figure out how we can separate this into separate classes, separate methods, so that we can have more reusable code. Let's take a look at what the instructions say. Okay, so let's create a new file called request.py and build out our class. Here's some code to get you started, but the code is incomplete. Take time to figure out what each line is doing. We want to create our own parse request method. So it should return a dictionary containing all the headers and all the HTTP requests. Okay, so this is a little bit more involved than I wanted it to get. Let's find out. So I'm going to create a new file called, why is this not working? Let's call it request.py. I'm going to split the screen to the right so that we keep both things open. I need to grab this here. What's this one? All right, and our whole goal right now is to create a request object, basically takes in the entire request, stringifies it, and gives us all the useful information that we want. So I'm just going to grab this and paste it in. All right, so it looks like it's just called request text. Okay, interesting. Looks like there's a whole bunch of stuff called self.parse request. So it looks like we've gotten something to get us started. So we know that when the request comes in from the client, that's this line over here, maybe we have to do request equals request with the client connection. All right, I probably don't need any of this anymore, but I probably need to bring it down here, so I'm just going to paste it in for right now. And it looks like if the request, maybe this should actually just be if the request has a, what did we call it? Oh, if the client request dot parsed request at URI is equal to that. Okay, that makes sense. So if the request dot parsed request at the URI is equal to that. So I know that I've created a request class. I'm going to need to create some sort of, it doesn't look like it's a method, it looks like it's an instance variable called parsed request. I need to save all the contents and put it inside of URI. So it's also broken in line 21. That's because we don't have from request, from request, import request. Now it's going away. From this file, bring in the entire class. That's what's going on right over here on line 22. So it looks like we can send over an HTML response, or we can send over the HTML time response. These two pretty much do the same thing. So maybe we could change up a few things, perhaps. Okay, let's pass in URI. So let's say that we're just going to pass in the URI. I'm going to get rid of this whole thing here. Create HTML response with the URI. We're going to say, we're going to pass in the request dot parsed request URI. And we've just cleaned up a little bit. Even though this is not done yet, we'll get to it. Let's move this over. You can kind of see all the code is starting to move out of this general area. So we're basically saying we're going to create a socket server, find localhost 92, let's change this back to 9292. And while it's true, it's going to loop over and over. We're going to wait for a connection, listen for something, and get whatever comes in from the client. We're going to save it as client connection and pass that into request. Request is a black box. It's going to parse through a bunch of stuff. But all we're going to do is we're going to save that as request and then access the URI on the particular request. It looks like request has something called parsed request, which is an instance variable. And that instance variable looks like it's a dictionary because there is a key of URI. Now, I said that this is pretty repetitive. It looks fairly simple to change. So what I'm going to do is I'm going to say if URI is equal to slash, I'm going to do one thing. Otherwise, if URI is equal to slash time, I'm going to do something else. So just by passing this in, I know exactly what I want. First things first, fairly simple, move this over, move that over. Otherwise, move this up here. That's all it is. I hate this. I'm pretty sure I could do this much faster. Interesting. Tell you what, I think I can get rid of this line because they're the same. So I'm going to get rid of this. Move this over. So from HTML response URI, create HTML response is going to take in a URI. If the URI is this, set the HTML as hello world. If the URI is slash time, do the same thing, but figure out what the current time is, and then return right there. I think we're able to do this now. Let's finish this up. So we said we had a request object class right over here. On there, it looks like it's a parsed request. Interesting. So let's say a request takes in a request text, and right away it has something called parse request, which means that I'm going to need to do def parse request. And it looks like, I don't even know what this is. Let's take this embed out of here and shove it in here instead. Let us figure out embed right there, move this over. We know we're going to need it at one point because we used it a little bit earlier. And let's see if we need a self here, we need a colon there. And let's see if this works. So from request, what is this? What's wrong with this? Cannot do this due to invalid syntax. From request, import that. I just do star. Leave go away now. Oh, whatever. All right, so let's go back to this Python. We're going to kill this. Run the server. It's just waiting for a connection at this point. I'm going to go back over here, clear it out, and let's just make a curl request. So it looks like it refused, and interesting. Why did that? Oh, I'm curling the wrong port. I curled to 9291, but I changed it back to 9292. Empty reply from server. Looks like parse request takes one positional argument, but two were given. Interesting. You know what? Let's actually put the embed up here before anything happens. So let's run the server one more time. Address is already in use, so let's change the port number. It's 9291. We're going to make a request to /9291, and it's frozen because we're right over here. All right, so we're stuck with this first embed. Let's take a look at request text. So request text is a socket object. Okay, so let's take a look. Can we do all of this stuff? I don't know. Ooh, okay. So this is the same stuff that we had a little bit earlier. I don't think we need all of this. Let's just decode it and not split it yet. No. Okay. It's because request text is interesting. Let's try this one more time. Let me kill the server on the other end and try this one more time. Address is already in use. Let's change the port back to 9292 instead of 9291. Start the server and make a curl request. Connection retrieve. Oh, okay, that's because I'm making a curl to the wrong place. So it's hanging out. Let's take a look. Let's just take request text with decoding and nothing else. So R. So we could just get this right over here. So we're going to parse the requests. I'm getting to this, but tomorrow we're going to have to create an actual. Tomorrow this is going to be a little bit more involved because we need to detect whether or not to get request or another type of request. So what I'm going to do right now, I'm going to get rid of this altogether. I'm going to come back over here. This essentially we just tested by copying and pasting it, and we're just going to set that equal to A. We know that A, we split. Oh, there, it's right there. If we split and take the first one, that's going to be what we want. So what I'm going to do is I'm going to create a parsed request instance variable set equal to an empty dictionary. I'm going to say that the URI is equal to, it's going to take in an argument of request text. What I'm going to do is I'm going to have this request text, copy and paste. And I think that should work. Let's exit out of here. Let's see if this whole thing just runs. Wishful thinking, but we'll find out. Server already in use, our favorite thing to see. We're going to change it to 9291. Run the server. Jump over here. 9291/time. The current time is 1537. With just slash hello world. You can kind of see that this is a lot cleaner than when we first started. We've separated everything out so that all of the logic for parsing and for trying to do everything doesn't all reside in server.py, but we've passed off some of the responsibilities to request right over here. On top of that, we have a HTML response that's a little bit less fragile than just creating two separate unnecessary methods. So we have an HTML response that takes in a single URI. That URI is going to produce HTML based on what you put in, and we return that out to the screen. Let's try hitting this from the browser. Is it 9291? It is. So 9291/time, 1538, as we can see up here. And if we just go back to slash, oh no, which one am I running it from? Unbound variable reference before the assignment. Let us see HTML equals, and return HTML equals, and return. And that should be fine. Maybe it was something that was in the background. All right, so we've got this port right over here, 9292, hello world. If we go back over here to /time, oh my goodness, this is very clearly unhappy with me. So it works the first time, and it blows up the second time. Interesting. Local variable HTML reference before assignment. So it blows up on line 11, right over here. And then also on line 21, which is right over here. Why don't we print out exactly what we're looking for? So we're going to have the request, parsed request at URI. All right, so let's run this again, waiting for connection. we're going to make a request to /time. So, boom. The current time is 1540, and it already blows up just from that. So /time and then /bad icon. Interesting. Unbound local variable. I wonder if we need to actually go back to the way that things were and do it like that. It's possible. Let's clear the screen. Run the server again. The port's already in use. Change the port number to 9291. All right, and we're going to hit 9291 /time 1540, and then it blows up already. Interesting. Perhaps it's going too quickly. Well, this is this will be a kind of a rabbit hole that I'll figure out. But I hope this particular tutorial was useful in understanding a little bit about HTTP methods, the request and response cycle, and just a little bit of what's going on underneath the hood. You're creating a server that's listening for any sort of request. It's running constantly. You get the connection once a connection has been made. You parse through the request, and then you're going to send some sort of data back and then close your connection. That's essentially how it works most of the time.